Most of the efforts in infrastructure as code type of tooling has been around hiding the API. Most of the tools around infrastructure as code allow us to define infrastructure typically in a declarative format, with the exception of maybe Pulumi, and to interact with different providers using the CLI. It's almost as if we forgot the benefits of using the APIs to do almost everything, and part of that everything is to manage different types of resources. But that trend changed. Now we see an increased number of tools that are allowing us to manage whatever we need to manage using an API, and there is no better API today than Kubernetes API. And that is especially important since we recognized that Kubernetes and Kubernetes API and scheduler and everything else is not only about running containers. We've been using Kubernetes API, not necessarily the whole package, but definitely the API to manage virtual machines instead of containers, bare metal servers, networking, storage, and so on and so forth. And that, of course, includes, but is not limited to, Kubernetes servers themselves. How about we try to use Kubernetes to manage Kubernetes? And there is a project that tries just that. That project comes from Kubernetes Special Interest Group, and it is called Cluster API. So let's explore Cluster API as an API for you to manage your Kubernetes clusters no matter where they are. Creating and managing Kubernetes clusters is complicated. It's actually very, very complicated. From the early days, we got kubeadm or kubeadmin that allows us to bootstrap Kubernetes clusters. But Kubernetes is much more than that. We need hardware, we need software, we need services, we need networking, we need storage. There are many things that we need. The complexities of managing Kubernetes clusters differ from one vendor to another. If you use managed Kubernetes offerings like GKE, EKS, AKS, and so on and so forth, then the process is relatively simple and straightforward. But if we want to manage Kubernetes clusters ourselves, if we want self-managed solution instead of something that is managed by somebody else, then things can get complicated very, very fast. So Cluster API project tries to simplify management of Kubernetes clusters, especially at scale, and it has specific goals that it is trying to accomplish. To begin with, it is focused on managing the life cycle, which is creating, updating, deleting, and whatever else we need to do with our Kubernetes clusters. It tries to provide the same declarative API no matter where our clusters are running. It can be on-prem or in public cloud or anywhere else. And finally, it is trying to be invisible. We are likely going to see other tools popping up that will use Cluster API behind the scenes. What I want to explore today is whether Cluster API is going to be the thing that all of us are going to use, whether it is ready for you to adopt it, and whether it makes sense to use it in the first place. Today I'm not in the mood of talking too much without touching my keyboard, so let me stop this introduction right away and jump straight into a demo and show you how it works, and later on we'll discuss whether it makes sense using it, and if it does, under which conditions. The biggest difficulty for this demo is to choose where I'm going to run it, because Cluster API supports quite a few providers. Almost everything is supported, and that's great news, and I will go through the supported providers later. For now, I just need to choose something. I do not want to use on-prem simply because there are no servers floating around this office. So I will skip on-prem, I will go for cloud, but I don't want to be biased and show you something in AWS or GCP or Azure, because then you would swarm me with comments like, hey, you're biased, you like AWS more than Azure, or you like Google instead of the other two, and so on and so forth. So I will choose a smaller player and do my stuff in, I don't know, Linux, DigitalOcean, why not? Let me use Cluster API to create and manage and do different operations with Kubernetes clusters in DigitalOcean. Now don't freak out and say I do not care about DigitalOcean, because whatever I'm showing you should work more or less the same no matter where your infrastructure is, because that's one of the goals of Cluster API. It is trying to provide a unified API that we can use to manage our clusters no matter where they're running, and that's a good thing. So DigitalOcean it is. Let's see how this works, whether it works in the first place, and so on and so forth. Now, before I start, let me tell you that I have a gist with all the commands, and the link to the gist is in the description of this video. So if you want to reproduce what I'm doing, well, You can. I did only two things in advance, two things that I will not show you, two things that I did as part of preparation for this video. The first one was to install Cluster API CLI, so I have the CLI already running in my machine. I will not show you how to install it, but the link with the instructions is in the gist, so check it out. And the second thing I did was to create a few environment variables. And that's all I did in advance. Speaking of variables, what matters from the perspective of Cluster API is that all the vendor-specific things are provided either as a config file or variables, and then the manifests themselves are more or less the same no matter where we are running. And that simplifies the things a lot because I could just change those environment variables and keep the same manifests and then start managing my cluster somewhere else. That's a nice thing because it provides a unified interface that we can use both to define what we want to have, to define the desired state, and also to interact with the API in the same way no matter where the clusters are running. Very cool. What matters for what I'm going to do next is to say that I will not use managed Kubernetes cluster. I will not use GKE or EKS or AKS or any of those. Even though I could, or maybe I couldn't, but I will get to that later. I want to manage it completely myself. And that means, among other things, that I need a virtual machine image that will be used to create the virtual machines on top of which my cluster will be running. So the first task, the first goal that I have in front of me is to create virtual machine image that will be used for all the nodes of my cluster. Theoretically, I could create those images any way I like, as long as those images contain all the tools that are required to run Kubernetes. I should be fine, but I did not want to make my life more complicated than it already is, so I will use yet another Kubernetes SIG project, which is called Image Builder. And the Image Builder happens to have already everything I need. It uses a combination of Packer and Ansible. It creates images with Packer, and then it configures those images with whatever is needed using Ansible, and it has also all the configuration files we need and all the scripts we need and so on and so forth. Let me skip through all that and clone the repo with the files that I need. Next, I will go into the directory of the newly cloned repo, and then to images and CAPI, which is short for Cluster API, and I will show you the make file. It's a huge one, huge make file that contains all the targets that I might need, including those for building images in DigitalOcean. The targets that matter in this context are those that start with build dash, build node, OVA, and GC, and DO. DO is what I want, is short for DigitalOcean, and I can see here that I can build Ubuntu 18.04 and Ubuntu 20.04 and CentOS 7, or I can build images of all of those, the three of those. I will go with Ubuntu. I prefer Ubuntu myself, and why not take the newer one instead of the older one? My target of choice is going to be Ubuntu 20.04, so let's build the image by executing make build do Ubuntu 20.04, and let's see what we'll get. In your case, it might work or it might fail. If it fails, it is likely going to fail because it doesn't have some of the dependencies. That is likely going to be Ansible or Packer. The script itself tries to install what we need. In my case, it worked with Packer, it installed Packer, but it did not work with Ansible, so I had to install Ansible myself. In any case, what I want to say is that if the script fails in your case, then you are likely going to have to install something manually, and that is likely going to be Ansible, if you do not have it already. And now the process is running, it is creating an image. This will take a while, it will take actually a lot of time. So I will use this opportunity to tell you that you should subscribe to the channel, and you should like this video, and you should join the channel as well, because that helps a lot keeping the lights on. So please do those things, or at least some of those things. And now I do not know how to entertain you while those things are running, while the image is being created. So I will fast forward to the end of the process, and then we can continue. It took like 15 minutes. That's a lot of time, especially for DigitalOcean, which happens to be faster than most of the other providers. But the good news is that it finished, it created the virtual machine, then it configured everything that needs to be configured in that virtual machine, and then it converted that virtual machine into an image, and then it shut down that virtual machine. That's the simplified version of the process that was just executed and took like 15 or more than 15 minutes. There's one more thing left, and that's for me to figure out what is the ID of the newly created image, because I will need that ID very soon. Actually, you can see the ID from the output, you see that last line, it says ID 96680, etc., etc. But I will ignore that for now, because what I really want to do is confirm that the snapshot was really created, and I can do that by listing all the images in my DigitalOcean account. And I will do that with declarative compute image list. And here we go. Those are all the images that I have, which is only one because I created only one image so far. And now I can get that same ID that I could have fetched from the output, but hey, why make it easy if you can make it complicated? The last thing that I need to do in relation to building images is to put that ID into specific environment variables. The DigitalOcean provider will expect me to have DO control plane machine image and DO node machine image variables with the IDs of the images that I want to use. I will use the same image for both, but in theory you could have different images, and probably you should have different images, but that would be the subject of a different video. And to finish it all up, I'm going to go out of the repository that I cloned because I do not need to build the images anymore. I might need to build an image later on if I want to upgrade the cluster, but we'll get there. For now, I'm going out of the repo and back to where I was. Cluster API delegates the task of creating and managing and destroying clusters to specific providers. So we need to install all the providers of the infrastructure that we are using. In this case, I'm using only DigitalOcean, but you need to trust me that you could install provider for almost anything. And the installation, or to be more precise, initialization, is through the command cluster_cattle init and then -- infrastructure DigitalOcean. So DigitalOcean is going to be our infrastructure of choice today, mostly because I wanted to use the cheapest option I can imagine. And DigitalOcean is right somewhere around the top of the cheapness leaderboard. And now I can create the cluster, or to be more precise, I will not create the cluster, I will create the manifest that will be used later on to create the cluster. And I will do that because I'm lazy. I could just open a blank YAML file and write everything myself, but that would be a waste of my time and your time. So I'm going to use the CLI to create all the manifests that I need, and the command is cluster_cattle generate cluster. The name of the cluster is going to be DevOps Toolkit. The infrastructure where I want to run the cluster is DigitalOcean. The target namespace is infra. That's where Kubernetes resources that will ultimately create the cluster will be running. And Kubernetes version that I want to use is 120.10, and the control plane machine count is 3. I want 3 machines to act as a control plane, and I want 3 worker machines, and I will store the output of that command into cluster YAML file. Most important argument in that command is Kubernetes version, which is set to 120.10. And that version needs to be the same as the version of the Kubernetes components that were installed in the image that I built earlier. I will show you later how to configure Kubernetes version that will be baked into VM images, but for now you need to trust me that the image I built is based on Kubernetes 1.20.10, and that's the version that I want to create, so I have to specify that argument here as well. It's a bit of a duplication of things, and you will see later that the Cluster API is not shy from using duplication, which is not necessarily the thing I like the most, but hey, not everything is perfect. The output that is stored in cluster YAML shows us what are the different resources that will be created. I will not bore you with explanation of each of those resources, at least not just yet. For now, what matters is that all the different resources that describe different Kubernetes controllers are in the file in cluster YAML, and we can apply those resources, and they will be created in the management cluster, and then Cluster API will use those definitions to create the actual infrastructure, the actual virtual machines, and whatever else is needed. Since I said that the target namespace is infra, I'm going to create that namespace, you know the drill, kubectl create namespace infra, and I will apply the resources that I have in the cluster YAML file. And you can see that I got the cluster and DO cluster and kubeadm control plane and DO machine template and machine deployment and so on and so forth. I got the resources that I need, and I will explain them later. Maybe I will, maybe I will not. Depends on how bored I am. For now, what matters is that we can use Kubernetes API to see what's going on. We can, for example, list all the clusters and see what we'll get. And we can see that there is only one cluster because that's how many clusters I created so far, or I wanted to create so far, and the phase is provisioning. So right now, Cluster API is doing whatever needs to be be done for that cluster to be up and running, to be operational. We can also list machine deployments, which is a resource that creates the VMs themselves. The cluster resource will try to tie them up later, but for now, what really matters is that machine deployments are working to create the VMs that I need, that we need. And we can see that there are 3 replicas. 3 of them were updated just now, and all 3 of them are unavailable. It will take time until all the VMs are created and configured and so on and so forth. So let me see what other resource I might want to show you. Yes, I know. kubeadm control plane is probably what you care about the most. So let's take a look at the control plane. What's the status of it? As you can see, there isn't much going on. All the columns are empty simply because there is no control plane. We cannot have a control plane until at least one VM is created. So I'm going to get back to this command later. To be more precise, I will wait for a while and then repeat the command, and if it's still empty, I will wait for a while longer and repeat the command until we get something. And since that part is boring, I will fast forward until I do get something. Here we are. We can see that this time there is one replica running. That one replica exists, but it is still not available. It will become available later, or to be more precise, it will never become available unless we do something, and I will show you later what we need to do. Hint, we need networking, and Cluster API does not install networking by default, which is kind of silly, but hey, many things are silly about Cluster API, but many things are great as well, so it's a mixed bag. So let me fast forward again and see whether we'll see some change over time, let's say 5 to 10 minutes. And there we are. Now we have 2 replicas. They are still unavailable and they will continue being unavailable. I will show you how to fix that, but what matters for now is that it says initialize true. So the control plane is initialized even though it's unavailable, and that's just what we need to make it available. And we will make it available by installing networking, and we will use Calico as our networking solution, and to install Calico we need kubeconfig. So I need to retrieve kubeconfig of the newly created, almost working but not really working type of cluster. So let me do just that by executing cluster_cutl --namespace infra. That's where resources were created, and I want to get kubeconfig of the cluster called DevOps Toolkit, and I will store the output of that command in kubeconfig.yaml. One thing you should not do is pause this video and try to get this key and try to access the cluster that I just created, because after I'm finished recording this video, I will delete this cluster. So do not try to steal kubeconfig from me, because that cluster will not exist for long. I'm just trying to save you from futile attempts trying to be wannabe hacker or something like that. Now that I have kubeconfig through which I can access the newly created cluster, which is still not working, but I can access it somehow, I can use that kubeconfig to install Calico, and I will do just that by executing kubectl. Kubeconfig is kubeconfig.yaml, and I want to apply the file that is stored in project Calico documentation. So let's just go through it. There we go. So let me hit the enter key, and there we go. I installed Calico as my network. Now, if you ask me, this should have been part of Cluster API or something like that, but it's not. It's a bit annoying that I need to set up networking myself. But hey, as I said before, Cluster API is a mixed bag of great things and half-baked things, so that's what we have. And to confirm that my cluster is really operational now, I will retrieve all the nodes of the newly created cluster. The status of all the nodes is not ready, so it will probably take a couple of more moments until Calico kicks in and connects all those nodes. So let me fast forward a bit more. A couple of minutes later, or 1 coffee later, the cluster is operational. The nodes, the status of the nodes is ready. We have 2 control planes and 3 worker nodes. But hey, wait, stop. I'm supposed to have 3 control plane nodes, not 2. 1 control plane node is missing. I said that I want 3, I got 2. Something tells me that I will never get the 3rd node because something is not working well in the DigitalOcean provider. I might be wrong though, so we'll see later. For now, I will skip waiting for the 3rd control plane node because 2 is enough. If I want 3 and I got 2, then I have quorum. I have the majority. My cluster should be operational even though one of the nodes is missing, and I don't have a good explanation why, but that doesn't matter because the cluster is operational. Actually, it does matter, but not for the demo. The ability to create clusters would not be very useful without the ability to upgrade clusters or update clusters or delete clusters, do other types of operations with clusters. So let's see how that works. What should I do? Let me upgrade Kubernetes version to something newer. Just as before, the first step is to create a new virtual machine image, an image that will have an upgraded version of Kubernetes components. So we'll go back to the directory where we were before, but this time I cannot just build a new image. I need to change a file that is stored in the directory packer config, and the file is kubernetes.json. So over here I will change the major and minor, or only major depending on the case. In any case, I will change Kubernetes versions all over this file. There's one, and there's a second one, and the third one. And how many more do we have? Fourth and fifth. Yeah, I think that there are 5 entries altogether. So let me save that file, and now I can execute just as before, make and build DigitalOcean Ubuntu 2004. Now, as you already know, it takes a lot of time to build an image. I think it's around 15 minutes, maybe even a bit more. So I will fast forward to the end of that process and see what we should do next. Now let me list the images to confirm that it was indeed created. So the command is do compute image list, and yes, it's over there. I can see by the name that it is Kubernetes 121.6 on Ubuntu 2004, and I will memorize or copy the ID of that new image because I will need it soon. Now let me go back to where I was and modify cluster YAML. That's the file that Cluster API created for us. That's the one that I used to create the cluster in the first place. But this time, since I want to upgrade my cluster, I need to modify that file. And this is where complications start. If you're used to manage Kubernetes clusters, this will sound ridiculous, but the process is as follows, more or less. We need to create a second machine template that will be based on the newer image. So we need to create a second group of nodes. And once those nodes are created, we need to tell the control plane to use that group of nodes and to shut down the previous group of nodes. And to make things more complicated, we should do that first for the control plane and then for the worker node. So long story short, we need to create new nodes, and then we need to tell the control plane to use those new nodes and shut down the old nodes. And then we need to create another group of new nodes for the worker nodes and tell control plane to use those and shut down the old nodes, and so on and so forth. It's a complex operation, and there is no way around it. We need new nodes, and we need to shut down the old nodes, and we need to tell control plane what those new nodes are, and so on and so forth. And the workloads should be moving from one set of nodes to another. We should do rolling updates. There are quite a few steps involved in upgrading our Kubernetes cluster using Cluster API. Those same steps are executed more or less in the same way, no matter which Kubernetes cluster we use. But if you're using GKE or EKS or AKS or any of the managed clusters, all that complexity is hidden from us because it's not our job, it's somebody else's job to do that, or to be more precise, the tools know how to do those things. But Cluster API doesn't know how to do those things, so we need to perform quite a few actions ourselves and change the definitions quite a few times. First time for control plane nodes, and the second time for worker nodes, and a couple of other things. It's madness. I'm so used to public cloud to manage Kubernetes clusters that this is something that I'm trying to forget. But if you're running on-prem servers, then you have to do that more or less, unless you have a tool that will do it more intelligently. But that tool is not Cluster API, at least not today. Now I will not go through that process in this video because it takes a lot of time. I want to keep this as brief as possible. You just need to trust me that the process could be better, and I'm saying that while ignoring potential problems, potential errors, and there are quite a few issues related to upgrades of the clusters with Cluster API. They will be probably fixed because the project is in early stages, but right now it's very complicated and shaky and tedious and So you need to trust me that the process is far from great, and I'm going to skip showing it to you. You go through the documentation if you're interested in using Cluster API and check it yourself. Instead, I want to talk about Cluster API. I want to discuss whether you should use it, and if you should use it, when you should use it, and stuff like that. So let's switch into pros and cons and conclusion and, the things that I do at the end of my videos. Let's start with pros, because that is going to be a shorter list, at least right now, while the project is still in very early phases. The biggest advantage I see of Cluster API is that it is based on Kubernetes API. It's about time that we use APIs to manage everything, and Kubernetes cluster should not be an exception. We should move away from the idea that APIs are hidden from us. We should move away from the idea that everything is CLI only. Using APIs to manage stuff is a great idea. It's something that we should all be doing with all types of resources, and Kubernetes clusters are not an exception. And speaking of API, I love the idea that the API itself is more or less, not exactly, but more or less the same no matter which provider we're using. So we can install all the providers we need, and yet the API, the interface, the definitions will be more or less the same no matter whether we want to create and manage cluster in AWS or Azure or Google or on-prem and so on and so forth. That's absolutely awesome. I'm very happy about Cluster API's decision to use Kubernetes API, to be API based, to have control plane, and to be more or less universal or uniform across providers, because that verifies some other assumptions that I've been making for a while. I'm just not sure whether the implementation of Cluster API is what we should be going for, but I'm 100% convinced that using Kubernetes API and all the other goodies of Kubernetes to manage stuff, no matter what that stuff is the direction we should be going for. I will get back to that in a second. For now, I want to jump into cons, into the things that are not so great. To begin with, Cluster API is definitely better than using kubeadm only and exclusively. There is no doubt, at least in my mind, that this is better than kubeadm, or at least that it will be better in the future when the project matures a bit more. However, it is still too complex. And I know that some of you are going to start throwing stones at me and saying, you do not understand the complexity. Complexity is good, but it's not good. I like the idea that things are easy. Things should be easy. And this is far from easy. We need to build images instead of providers giving us images already pre-built and us building images only if we want to do that, not because we have to do that. The upgrade process is horrible. It takes me back to where we were maybe 5 years ago. I do not like it. It's what EKS was at the very beginning, and even EKS, which in my opinion is not a really good Kubernetes service, moved away from such type of upgrades. No matter which tool you choose today or which service you choose, upgrades will be, hey, I want new version of Kubernetes, I want this specific version, let me execute this command or let me start this process, and that's about it. There are no steps involved like, hey, let me change this, execute that, and change this and execute that. Simply put, it is not user-friendly. Another negative thing with Cluster API is that it is only for Kubernetes clusters. That by itself should not be necessarily a very bad thing, because there's nothing wrong saying, hey, we use this tool for this and that tool for that. It's okay to say this tool is specifically designed only for Kubernetes and infrastructure around Kubernetes, and you need some other tool for something else. But we already have tools that do more or less the same things that Cluster API is doing, except that those tools are having much wider scope. We have tools that are managing not only Kubernetes clusters and infrastructure related to Kubernetes, but everything, any type of infrastructure, any type of services, and any type of provider. And that tool happens to be cross-plane, but I will get back to that later. Another thing I don't like right now is that EKS is the only supported managed Kubernetes cluster. Everything else is self-managed. So if you want to use Cluster API to manage a Kubernetes cluster in Google, you will not get GKE. You will get self-managed clusters. You will get nodes in Google Cloud, but you will not get Kubernetes as a service. You will be managing it fully, completely yourself. The same thing goes for other providers, for Azure, for Alibaba, and so on and so forth. Self-managed is not necessarily bad. It's good for on-prem, maybe sometimes, at least not always. And there are situations where you do want to have complete control over your Kubernetes cluster, even when you're running it in public cloud. But for vast majority of people, at least those running in cloud, managed Kubernetes clusters are the way to go. You want to use EKS and AKS and GKE, and even DigitalOcean that I used has managed Kubernetes service. I think it's called DigitalOcean Kubernetes, something like that. Anyways, this is not giving you managed Kubernetes except for EKS. So we are limited mostly, with exception of EKS, to self-manage Kubernetes clusters, not manage Kubernetes clusters, not Kubernetes as a service. We cannot create those with Cluster API, at least not today, at least not in November 2021. And that makes me think that Cluster API is not really a good solution for anything but on-prem clusters. If you want to go cloud, there are better tools to do that. Some tools that exist already for many years, some new tools, I will comment on those later, but there are better tools to do the same thing more or less. Another important thing is that in November 2021, the project is very green. It just graduated from alpha to beta, but providers are very shaky. Even though Cluster API itself might be working very well and might be production ready, providers are not. You saw me using DigitalOcean. I wanted control plane with 3 nodes, I got 2. Nobody knows why, but that's what I got. Upgrades are sometimes working, sometimes not. There isn't enough information in logs. Events are non-existent, more or less, and so on and so forth. So it is still very, very green, but it has a bright future. Or maybe it doesn't. It might have a bright future. We'll see about that. And the last thing is the chicken and egg problem that all the tools of that kind are having. You need a Kubernetes cluster to run Cluster API, just as you need Kubernetes cluster to use Argo CD, and you need Kubernetes cluster for other tools. Kubernetes is becoming the de facto standard, and there is an increasing number of tools that require Kubernetes cluster just to start with. But since Kubernetes is more or less commodity, that shouldn't be a big deal. So here are a couple of big thoughts. To begin with, Cluster API might be a good solution if you're running on-prem. I would not really use it for cloud, at least not in the state it is right now. It has a potential for greatness, or actually it would have potential for greatness if it was created earlier. The ideas behind Cluster APIs are great, but we already have tools that do the same thing as Cluster API, except with bigger scope and more mature. And if you watch my videos, you probably know which tool I'm talking about. That's Crossplane. Crossplane is doing the same thing that Cluster API is doing, plus many other things. The scope is much wider, it's not limited only to Kubernetes, and it is based on similar principles. It is based on the idea that we have control plane to manage our resources. That control plane is sitting in Kubernetes. We are using Kube API to do stuff. So the principles are the same, except that Crossplane is more mature, it has additional features that we might need, and the scope is much wider. Because let's face it, most of us do not need only Kubernetes. There are always other things that we need to manage, other things related to infrastructure or to services, and this one will not help us with this. This is very similar to what TKS Cattle is doing, except that it is based on Kube API, which is a huge bonus, and that it can work across multiple providers, but it is still limited only and exclusively to Kubernetes, which would be great if we don't have tools that already do that with wider scope and more mature, which again is Crossplane. There are a few others, but Crossplane is the one that is closest to being that type of software, widely accepted type of application. Now comes an important note. I'm very heavily involved with Crossplane, so you might consider me biased. I'm trying not to be, but you never know. So you might say Victor is saying bad things about Cluster API because he's promoting Crossplane, and I am promoting Crossplane, but I'm doing that because I believe that it is indeed a better solution. Now, whether you trust me with that statement or no is a different question, right? Now, before I leave, I need to tell you a bit about my feelings. I feel really good after using Cluster API for a while because it made me appreciate cloud even more. I got so used to GKE in Google Cloud and EKS in AWS and AKS in Azure and Civo and Linode and DigitalOcean, and I used managed Kubernetes services in all of those that I forgot how painful it is to create and manage Kubernetes clusters yourself from scratch, which is more or less what Cluster API is doing. It is a better choice than kubeadm, but not necessarily a great one, at least not today. Now we'll see where the project will go and where it will be in half a year, but right now I'm not convinced.